I'll just repeat that, right? So we're going to look at pivot tables. We're going to set it up here in the Google Colab, which is a Python notebook. For the pivot tabling, we're going to rely mainly here on Pandas and NumPy. We're not going to do machine learning, but it turns out that the Boston price dataset is actually embedded in one of the sklearn libraries. So we're going to make use of that, and we can do a bit of graphing as well, just to see the matplotlib and cburner for graphing. So we'll execute that. Those libraries will load in. We're connected to the server here. And then, as usual, then we'll pull off from the sklearn datasets the Boston house price dataset, and then we're going to refer to this data. So the Boston data, we're now have created an object using the pandas, PD denoting the pandas. We're going to create an object called data, and if we look at that data, it doesn't carry the labels, but you can see we have the first whatever 5 observations here. If I put in 10, I get 10. The first 10 rows, or I could put in the tail. But we need to pull down the labels, so criminality, and then we've an expression here for the proportion of residential land zoned. So each of the labels here, you can see the attributes. We've provided some explanation of what each means. Criminality, the proportion of residential land zoned for over 25,000 square feet. So the bigger the lot, the more probably pricey you'd expect the property. And remember, we're trying to predict also here the median price of the property. It doesn't appear here, right? But the median price in a 506 electoral districts. The NOx is the nitric oxide, so it's the amount of pollution. The age of the property, the distance. Now this is important, the weighted distance to 5 Boston employment centers. And then RAD is the index of accessibility to radial highways. So the higher these are, the more access you have to either employment in terms of just physical location, right, weighted distances, or in terms of infrastructure, right? And so in the original study that was done, and I just draw your attention to it, for the original paper, it was Rubenfeld and Harrison, right? And they were looking at the relationship between house prices and clean air, right? That's what originally they were looking at. And I suppose they were, what they were trying to examine was the amount of pollution. If you had higher level of air pollution, then did you have lower house price? But if you looked at a map of Boston, right, like what we have here, for instance, you would find typically those places that have the best infrastructure, proximity to the areas of employment and to radial highways, are also the areas where typically you would get where you would have higher pollution. So and also if you lived along the Charles River here, right, you might expect, typically if you have proximity to a river or a lake, and so long as it's not prone to flooding, typically the property would be more valuable, right? So in this data set, we're trying to capture that obviously pollution would be something that would be regarded as a negative and would weigh negatively on the price or the value of the property, right? So the nitric oxides would have a negative effect, you would expect, on the value of the property. But then if you had access to better infrastructure, right, or access to more, weighted distance to employment centers, you would expect these would be positives. Now, as we go down through, now we better load in the labels and bring in the target, which is the price. And then load in, we can see the shape, 506 rows, 14 columns. And if we load everything in, you can see the unique values. The Charles River is a 1-0 type value for the zones here, 26 different values for RAD. There was 9 different specifications, but for distance 412, right? So we'll see in a moment why these are relevant. If we're doing, if we want to create categories, we could have 9 categories. That'd be doable. We could have 2 categories. You either live close to the Charles River or not. But it's difficult to extract much meaning out of 446 separate values or 356 separate ages, right? So if we're going to create categories, it probably restricted to RAD and to the Charles River, right? And we can check to see if there are any missing values, and there's not. It's sort of a pristine data set. And we can see we have, okay, so I better go back and just make sure that our labels are correctly attached. And yeah, data columns, Boston name. So we've attached, let's load in this, the feature names. And now execute this. Okay, not working. Let's see, so we'll just execute again, all 3. And the Boston feature names. Okay, so finally, so what we have now is the columns and the variable, the labels here, okay? And again, if we run, we can see we've now included the price. So this is our target variable, and this is what we're trying to predict. In other words, we're trying to predict the property price. It's the median price of the property for an electoral district, and there's 506 electoral districts. And you can imagine criminality would have you'd expect the higher the amount of crime, the more negative that would be on the price. And we can see the different relationships. Now, when we go down, there's a very nice graph there that we can look at just to get an overall sense of what the relationships are with the variables. And we have descriptive statistics, great. So we've box plots. I'll just skip through the box plots for the moment. But if you look at this, we kind of see a little bit the relationship between the price of the properties and then, if you like, each of the attributes. So the higher the amount of crime, the lower the price. The more you have bigger lots, the higher the price. If you have more industrial zoning, the lower the price. If you live on the Charles River, which is 1, and there wasn't that many, the price seems to be a bit higher than if you don't live adjacent to the Charles River. NOx is the amount of pollution. So the higher the amount of pollution, the lower the price. RM is the number, I think it's the number of rooms, right? Typically in properties. So RM here, we'll just go back, average number of rooms per dwelling. So if you're in a district where the number of rooms is higher, then that's a very strong predictor of a higher price, right? If the age of the property is higher, the price is a bit lower, but that might be associated with something else. And normally age is not a negative factor weighing on the value of a property. If properties are older, they might be in better located, more central districts. The distance, this was the distance to 5 employment centers, and we can see here a positive relationship. But then surprisingly enough, the RAD, which is kind of an index of proximity to infrastructure, good like the highway structure, that has a negative impact. But you could imagine a situation maybe if we didn't have this there's a value of 24 over here, and maybe that's pulling the trend line down, right? Increase in taxes, more negative. If you've more pupils to teachers, the more negative the price is. That's what we might expect. B, I think, is again, I have to check the formula for that. There is a formula there. I think it's some kind of ethnic proxy, but I'm not 100% sure. And then LSTAT is the lower status, and I think it's the proportion of people with who don't have high school education, right? High school diploma. So if you have more people without high school diploma, the value of the properties seem to fall. Okay. And then we have a correlation matrix. And then for the pivot table, we've some definitions there for DIS and RAD. And I took this, I don't think I took it from the paper. I took it from somewhere else, if I remember correctly. I might go back and check that. But the key thing is the pivot tabling, right? And so what we have, let's just look at this. This is using the Pandas library and the pivot table function, right? And basically we can say, look, can we set up our table so that the index, we just create a column of data, right, or a row of data, 2 rows of data based on the categories of CHAS. So this is the Charles River, right? So do you live close to the Charles River or not? And if it's 0, you're not on the Charles River. If it's 1, you're on the Charles River. And notice that if you live closer to the Charles River, the price here is higher. Now, what is this price? It's actually, even though it's not explicit, it's the average price, right? And we can, using matplotlib, pull out a graph there. Maybe the graph is not that revealing, but it's we could say, I mean, if we look here at the price for the moment, which is the red, the price is higher when you're on the Charles River, right? And so again, that's a very basic pivot table, an interesting one, and one where you can say, yeah, if you live in the Charles River, the mean value is higher than otherwise. Now, there's other factors, right? But that's something that we can observe. Again, if I just get rid of this for a second, if I had put in the same syntax, right, as what we have here, and just put in and then estimate the mean for each of the observations, you'll observe we're getting exactly the same result, right? So using, again, PD pivot table, saying the data is equal to what? It's the data. Remember, we referred, probably a bit absurdly, but the Boston data set here, we created an object and called it data, right? So it's a data frame with 506 rows, 14 columns, right? And we then create an index, which means split the data up into the categories. And the Charles River, it's a binary type thing. You either live on the Charles River or you don't. And then just get the mean value. NP is NumPy. So we're using NumPy to estimate the mean for the each of the 506 rows, right? But based on whether they're on the Charles River or not. Okay, now it's the same. So even though I haven't made explicit here np.mean, it is the mean, right? Now, if I do the same syntax again, but put in median, which means typical, it might be more revealing, right? Typical, median means typical, right? So average says something and median says is not, it is also a measure of central tendency, but it refers to what typically do you expect, right? And typically house prices for on the Charles River, the average of those prices, so it's the median of the medians, right, was 23. And if you're not on the Charles River, 20.9. Okay, so a bit of discrepancy between the two. Now we could say, look, I don't need everything here, just too much. Could I take what I had here and just limit it to one or two columns? And again, it's the same syntax. Data is equal to data. Index is equal to Charles River. We'll say the value is equal, the values are equal to the price. So I just want to take the price here, and then we're getting the mean value, right? And you can see the value. Well, I could change this to, well, it's this one here. Look, the price 2209 2844, 2209 2844. So again, I can, the idea of the pivot table is you have this massive maybe data set or large spreadsheet, and you can summarize it with a smaller table by introducing categories. Again, we could do the create the index again for Charles River, but also remember RAD is the access to radial highways. If you have good access to infrastructure, typically you would say that's good because, you know, better infrastructure, better roads enhances your quality of life. But then if you live next to a road, or if there's a lot of pollution caused by that road, that has a negative impact. And in the original paper, they wanted to incorporate in the negative effects of living in a city center location where there was pollution, while like at the same time balance that out with a variable for proximity to good infrastructure, proximity to employment, right? Now, look at the way this is set up. PD pivot table, we're using that function, and the data is the data, right? So it's the 506 rows, the 14 columns. And then we're using the Charles River and RAD. And remember I said RAD had, there was 1, 2, 3, 4, 5, 6, 7, 8, and then it jumped to 24. So there was 9 categories here. And also here there's 9, but we're missing 1, we're missing 6, and we're missing 2, right? Because actually it turns out there's not that many properties, not that many electoral districts on the Charles River, right? Okay, so we have what we would say, look, if you live in the Charles River, typically the properties might be a bit more. And if you're here 1, so on the Charles River, so an electric district on the Charles River, the median price was 50 here. You don't have great access to highways, but you are on the Charles River. Now, what you're probably getting there is if we look at it, it's the pollution. Let's look at the NOx side. It's 0.401. Now come down to where you have 24, which means very good access to motorways. Look at what's happening to the pollution. It's a good bit higher. And also look at the criminality. Here it's really low, but here it's really high. And then look at the age of the properties, right? On average, you know, here it's lower, here it's higher. That in itself, age is not normally a problem. It doesn't necessarily weigh negatively on the value of the property. But if it coincided with place of high criminality and you had relatively high pollution, and the pollution looks to be higher here, You can see the price is 20, median price 22.30 is a lot less than the 50. So access to good infrastructure doesn't necessarily guarantee you a higher price, because possibly what you're getting is higher criminality, right? And over here, you're not on the Charles River, so electoral districts off the Charles River. Here where we have 24, we look at the property price, it's really low, right? $14,000, right? So good infrastructure is not associated here with higher price, because we're getting a few things. We're getting this high level of crime, and you're getting more industrial zoning, and there's a higher proportion of people without diplomas, high school diplomas, and look at the level of pollution, it's very high. Okay, so you're kind of getting that out of, you can create the pivot table, right? And you see what we're getting. Look, we can put in these dimensions into our, create indexes, which allow us to summarize the data, right? Now, we could have also used data groups. So this is the data set, the 506 rows and the 14 columns, and we can use group by verb, right? And it allows us then to accomplish something similar. We could say, look, the Charles River, so group by, and then the Charles River and RAD, right? And we could go by age. And let's see, yeah, it's the same, right? Or I could say, look, price. So group by is another way of doing a pivot table here. Let's put in price, P-R-I-C-E. Let's execute that. And you can see, look, 22, 23, 26. 22, 23, 26. Right? So I'm able to narrow down. Group by is a nice way of running our the same type of query, and we can target a little bit what it is we want, right? So we wanted the median price, but I could also say here something like, well, maybe I'd like to look at the maximum price, the maximum, right? And I want to look at maybe the minimum price. Okay, so again, you can create whatever query you have to narrow down your focus based on these categorizations. You're looking at the price, and you want to identify the minimum price, right? How many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I'd run this query again, but just put in count at the end, I'd get that 15, right? But if I wanted to, if say, for instance, I wanted to, let's go with price again here. If I want to get the number of properties, the number of electoral districts that satisfy these conditions, right, I could just do count, right? So if I run that, I'm getting, well, it's not actually throwing out price at all, median price, it's just counting. And for instance, if I removed RAD and just left in Charles here and executed that, what we can observe is there was 471 electoral districts that were not adjacent to the Charles River, but there was 35 that were, right? So it's, or I could have written it this way either, and I would have got the same result, right? So what pivot tables allow us to do is create a table that summarizes a much bigger table, or a much bigger spreadsheet, and that can be very useful, even specifically for